starting a second period.
So,
Hi.
morning.
Good morning. Why do I sound the most awake in class and I've had like 3 hours of sleep? Okay, let's take our, hopefully 1 page of notes. My last class it went over just because I started writing really big and crazy. So I'll make it smaller so it fits on 1 page as per our usual. Here we go. We're going to do some algebra connections to start off the next little segment that we've got going. We're going to talk about ratios and what they are. So I need to start off with a definition. Just one, ratio. I'm going to zoom it in a little bit more so that it's easier to see. There we go. Ratio, please ignore the squiggle at the very end of it. A ratio is just a fraction, which is to say that it is a value, and I'm using value instead of number so that way it can kind of carry on for you into any other maths you may need to take. So it's one value divided by another value. Can I have some examples of ratios and fractions? One, you said 1 to 1? All right, notice how I wrote that because that's what he said, 1 to 1. 1 to 1, which as a fraction can be written as 1 divided by 1. So all of those kind of mean the same thing. Nice. Can I have some other fractions?
2 to 2.
2 to 2. We've got the same setup, 2 over 2. Can I have something else? Different, crazier one? 102 over
20.
1020. All right. So this is kind of what we've got going on. Okay? These are fractions, these are ratios. Seems pretty simple, yeah? All right. Let's do some number examples that can help you out with some of the practice pages you're going to see in your blue book. This upcoming one is what you're going to see on page 103. You're probably going to see something like simplify the ratio. And then you're going to be given some fraction. So can I have some fraction? Or should I grab one of the ones from up here?
No, I'll make you
Make
10
some.
over 20.
10 over 20.
2 and 1.
All right, 10 over 20. Can this be simplified?
Yes.
Yeah, because there's a common factor. There's something that you can divide the top and the bottom both by. By 5, by 2,
By 10.
by 10. You're all right. You're all correct. The question is, which one gets you to the simplest
10.
faster?
10.
10, the biggest of them. Now, you're saying to divide both the top and the bottom by 10, and so I've seen on a lot of papers written like this, and I think this is how most of you guys are familiar with. What you guys are familiar with, yes? And you'd end up with 1 over 2? Okay. I'd like to show you kind of the same idea, but written in a slightly different way and thought about in a slightly different way that can help extend for you into the higher level maths that you're going to be taking after me. Okay? So we're going to have the same problem, the same fraction to reduce. I'm going to put a bar so you can see the difference. And then I'm going to use the equal sign, not because what I'm about to write is the answer, but because what I'm about to write is exactly the same as what came before it. I'm going to think of this 10 and this 20 as a string of factors, a string of things we multiply together to get 10. Since you identified here that they both had a 10 in common, I'm going to think of 10 as 1 times 10. And I'm going to do the same thing to 20. 20 I'm going to think of as 2 times 10. Notice how now we've got our common factor very clearly visible here. And if I do just this division right here, if I ignore everything else and I do just this division, I get 10 divided by 10, which is 1. And I'm making it very clear by writing the 1 up there, because it doesn't just poof disappear, it doesn't turn to 0, it is 1. But notice I had multiplications here, so this basically becomes 1/2 times 1, and anything times 1 is itself. So I'm left with 1/2. Okay?
Yep.
It seems, when it's with numbers, okay, when it's with just simple numbers like this, yes, it looks like it's more work. But I want to urge you and encourage you to consider starting to think this way right now when it's just numbers and easy. Because when you hit Algebra 2, these are going to get more complicated. And it's going to look impossible, but this technique is going to be the exact same thing. And the only hard part about it is trying to figure out what this same factor is. Okay? So if you don't keep anything else from my class, I'm going to ask you that you make this one of those that you keep into next year. I'm going to put a little hourglass. Okay? To ask you guys to please consider thinking about keeping this one page. Take a moment and write somewhere off to the left or underneath it that this technique, while it looks really complicated with simple numbers, is the easiest and fastest way to do it when the fraction gets more complicated. Did you have a question? You've got a thinking face.
How'd you get 10 to 10? Did you just divide it by 10?
Because you had told me originally 10 is the biggest number that is evenly divisible into each one.
When you do that, you're already getting the answer because didn't you already get 1/2?
Mm-hmm. Yes.
So what's with the...
But she's showing you something else because it's like, oh, she didn't do it in the first
Are you
place.
trying to like check your work or something?
No, I'm giving you a different option, a different way to do it, which with numbers seems more complicated than this one, which is kind of like a shortcut.
Pretend like that one isn't there. Pretend that the first one you didn't do the first one. So it's like if she's doing it and she didn't do the first one, she's actually just doing that one. Get it?
I get it, but it's kind of like another way to...
Yeah, it's another way to do it, another way to look at it, another way to think about it. Which right now, whichever way you can, right now, whichever way is comfortable is definitely the way you want to do it for, those high-stake test things. But when you're practicing, I want you to consider trying to practice with this one and struggle a little bit and get yourself out of the comfort zone. Because when you hit your maths in the upcoming years, Algebra 2, Pre-Calc, Calculus, whatever you happen to be taking, this skill is going to become very important for you. Okay? So it's not something you might do this year, but it will be something that you will need to be able to do in the upcoming years. And so I wanted to give it to you in an easy way here so that you can see it. And so I'm putting my little hourglass to remind you guys, here's my sand, that this is something, if you don't keep anything else from this course, this is something that I'm going to encourage that you do keep. Take a moment to write down a little thought about that. Yes, sir?
It's weird that I already did Algebra 2.
So a lot of the stuff you're seeing, like, oh yeah, that was what we did? Cool. So he's definitely giving you the insight for some of the things that I'm going, hey, you're going to need later. Thank you.
Algebra 2 is like way harder.
Yeah. Well, I'm sorry that it was hard for you. All right, let's try a different example. Let's make some of these fractions. Let's make some of these fractions just a little more complicated.
I don't need a little more complicated. I need a little more easy.
Okay. We're gonna add a little bit more to it. Hopefully this little bit complicated will turn things a little bit easier. If you're still stuck, come see me.
Example?
Yeah, it's another example.
No, but I mean under the example, the EX, it's
Page 104. Now, page 104 isn't assigned, but this is where I got the information from. Okay? It's going to say, find the value of x. I'd like some numbers, throw an x in there. Just numbers, don't do any plus or minuses?
22.
2x over 22. Okay, give me some more numbers, no x's this time. 23 over
4.
44. I'll combine the two. Okay, so we have this really weird looking fraction. And we have to solve for x. The first question I want you to ask yourselves when you see this is, what do I see?
A lot of numbers and an X.
A lot of numbers and an x, okay. What kinds of structures in the numbers do you see?
I see a lot of 2s.
Fractions. So structure would be how they're put together. So we see some fractions. And what kind of sentence are they in? Are they in just an expression, or are they in an equation?
They're trying to make an equation.
Equation, because of that equal sign. If it didn't have the equal sign, if there was like a plus or a minus in between them, it would be what's called an expression. It just says something without giving you an equivalence or a relationship. So this is an equation with fractions. Now, we've dealt with some of these before, haven't we? When we did our linear functions and we had our slopes, those were fractions. We had equation with fractions not too long ago when we were doing the mid-segment, which was half of that third leg, right? What was our technique to handle the fractions in those equations? What was our technique to handle the fractions in the equations that we've seen before? What did we do?
We had to find a
Common something, yeah.
common factor.
Yeah, common factor or something, yeah. And what was the goal of finding this common number?
So you can simplify it.
So you can simplify it? So you get rid of those darn fractions, right? Yeah, because the fractions are weird and crazy, and who really likes fractions much anyway, right?
No, I'm just kidding.
So our whole goal right now is to get rid of the fractions. And as she was mentioning, our techniques for that so far has been to kind of multiply through by that common denominator, the common number at the bottom, and that would get rid of the fractions. The thing is here I have more than one denominator, and it's kind of hard for me to tell what the common one is between these two numbers. Or could be if the numbers are crazier. They're hers. Have you seen this sort of setup before? And what have you been wanting to do when you see this sort of setup?
Take out the X. Find out what X means.
Yeah, find out what x means. What kind of techniques have you used before?
X.
Cross multiply, right? And the full answer is yes, you're going to cross multiply, but let me tell you why. So that way when you see structures like this coming up next year, Luis hopefully can collaborate with me and say, yeah, we totally did stuff like that. It'll make more sense. So here we're going to cross multiply because, and the reason is super important, I have one fraction equals one fraction. And this part right here is what's important. It has to look like that. You have to physically see one fraction equal one fraction. Is that what I have? Then I can cross multiply. If I have something that's not one fraction equal one fraction, I cannot cross multiply. And if you try, it's going to break stuff. So let's go ahead and cross multiply. Again, we're kind of back with our statements, reasons bar, because we are in geometry, not just algebra.
I have lost space. I do not have any more space.
I'm going to change colors a little bit just so that you can kind of keep track of what we're doing here. I need help with that multiplication. 20 22 times 23. I know that we don't have any calculators right now, so use your calculator app on your phones.
That's the day my phone dies. It's
The day the cell phone died.
606.
606?
Thank you. Make sure.
So, yeah, someone double check it.
Yo, what's up, miss?
22 times 23.
Probably wrong.
He said 606.
506.
506.
506.
A plus for close. A plus for close. And now this looks familiar, doesn't it? From here, what should I do?
Divide 88.
Yep. Divide both sides by 88. All right. So x equals 506 divided by 88. And this would be one of those moments in which you would need to simplify. Please know that you need to simplify all of your fractions from here on out. And simplify doesn't mean turn it into a decimal. It means write it as a fraction, but where those numbers are the smallest possible. The TI calculators will do it for you. The TI calculators will do it for you. We don't have them today, so I'm going to think through. They're both divisible by 2. Now I'm going back to the other one. Help me out with this, guys. I'm not good with these kind of divisions. 253?
Wait.
Someone with a calculator app.
What's up, miss? I got you.
506 divided by 2.
So
I know the denominator is going to be 44. I can do that one in my head.
253.
253? Is that what I said?
No.
Said 250.
I said 258. I was wrong. Okay.
254.
Okay, and I don't think that we can simplify it again after this. All right, take a moment, please. And here in the right-hand side, write down for yourself reminders of what you did at each step. Take a few seconds right now to make that happen.
Oh, my neck. Miss, have you heard the test?
No?
My cousin showed me the song and I just had it stuck in my head, and then this morning they played it in the bus, so now I have it stuck in my head again.
If you're out of space, go ahead and go to the back. I'm going to force myself to get this onto one page. So I'm going to write a little smaller than I have, because that's all the space I have left. All right. This one is coming from one of the pages that are assigned to you, page 106. And we're going to copy question 12, but we're going to change the numbers. Okay? So it's not going to be exactly the same, just the process will be the same. So I'm going to have given line segment AB divided by line segment BC. So now we're using geometry to name things. But the algebra process is going to be exactly the same. So there's our statements. Here's our diagram. And I need some numbers from you guys.
22.
Okay. More numbers?
Okay.
From someone else?
59.
I heard 59. Give me another number bigger than 59, please.
60.
I heard 60 and 31. Let's combine the two and make a really big number, and let's do 631. So really big number. 6 and 31, I kind of mashed them together. We got 631. All right, so let's fill out what we know and then see what we need. I know AB is 22. Shall I zoom in?
Hold on.
Because I'm realizing that I'm writing really small.
AE 59.
AE would be 59, yes. So let me, AE is 59. And then BC, I have no idea what it is, so I'm going to use a variable to represent, hey, I don't know what this number is. And our default variable is X. And then I need ED. Wait, I don't know what ED is either,
Why?
because I don't have a number
No,
there.
I mean like put the letter Y.
Oh, however, look, if I were to cover this, I would have that old segment addition postulate thing from way back when, remember?
I know.
All right, so tell me what ED needs to be.
Wait, you subtract 631 from 59, and then you get.
How much?
572.
572, and you did the subtraction she was talking about? You did the subtraction she was talking about? You were awesome. So now I have ED is 572. I left a space right here for BC. I'm going to go back and fill that in because this is the one I don't know. All right, I'm going to use this now to write that equation. I'm going to rewrite it, start from the very beginning. Just like with our proofs, we're going to start with our given. And I'm going to use substitution to replace all of those line segment names with the values that I know or the variable for the values I don't.
Is this when you cross multiply and divide by that?
Yes. Why are you cross multiplying?
Because you have two equations for 2%.
Because I have a fraction, one fraction equals
And then you divide
one
with
fraction.
the number.
Exactly. So go ahead and make that happen. Someone with a calculator app, get those numbers ready for me, but don't shout them out right now because I need to do the little colored work here so that way it can be seen.
Just do
Okay, give.
22 times 572.
All right, give me that number.
12,584.
12,584. Okay, hang on.
Okay, put 12,584.
All right, there's that.
The answer is 213.288.
213.28. So 29 will round. Okay. When the numbers get really gigantic like this, I'm okay with decimals because trying to reduce the fraction you would get from this would, like, you'd want to shoot yourself in the head. And I don't want you guys to commit suicide. I really don't. Okay? Not even with water guns. I don't want you to get your temples wet with water. So when the numbers get really big,
So when we take a shower, that's
when the numbers get really big, calculator. When you're working in the blue book, the numbers are not going to get this big. The numbers got this big because we just totally made some up. Okay? Did we do what we were asked to do?
Yes.
How so? I only have a value for x. I don't know what BC is. I was told find the value of BC. I still don't know what it is. What's the value of BC?
Wouldn't that be X?
Yes.
213.
Now I'm done.
All the work.
All about that work.
What about taxes?
I won't sing, I promise. All right, that's it. Questions?
Comments, observations?
Suggestions?